All right, here we go, ready to tackle question 2017, number 5. So this one looks a little intimidating. Just to be clear, there are two different functions they're talking about. There's function P and function Q. So two particles move along the x-axis. They give you the position of P, which is this, and notice how x stands for position, and then the function they're talking about is P. And then they give you the velocity of Q. So V stands for velocity, and the function is Q. And then they give you this nice initial condition about Q only. Okay, so it's important that we keep everything straight before we even dive into the problem. So now most people are really good at these velocity functions. So let's see how well we do here. When is particle P moving to the left? So the two things I have to be cognizant of is P, so I know which function I'm talking about. So the only one I'm looking at is P, which was the position they gave me. So that was the ln of t squared minus 2t plus 10. And then they talk about moving to the left. Okay, so as soon as they say moving to the left, I'm going to justify. That's when my v of t is less than 0. So if I have v of t, I'm just going to set it equal to 0 and solve. If I don't, I need to go get it. Notice in function p, they gave us position. So I need to go get velocity. So I'm going to say v of pt. So now I'm finding the velocity. And I see an ln, and immediately I'm saying du over u. So my u is t squared minus 2t plus 10. And its du is 2t minus 2. So I'm taking that derivative and I'm setting that equal to 0. Now just to recall, when you have a fraction, you set both the top and bottom equal to 0 because we want to know when the function equals 0 and when it's undefined. So here I'm going to solve. I'm going to get t equals 1. This spare doesn't factor, so I'm done with that. So now I'll make my sign chart and answer the question. I'm going to plug in a 2 into my velocity. So I'm going to go back to this function that I'm boxing in. I'll box it in blue here. 2 times 2 is 4, minus 2 is positive, divided by 2 squared is 4, minus 4 is 0, plus 10 is a positive. So I'd say that's positive. And then I'll plug in, I'm going to use a 1/2 here. And the reason is I believe its velocity is about time. So they should have given us a lower bound of 0. If you look back in the directions, I believe they did. So if I plug in a 1/2, half of 2 is 1. 1 minus 2 is a negative. 1/2 squared is a 4th, minus 1 plus 10 is definitely a positive, so I get a negative here. So to answer the question, I would say the particle is moving to the left from 0 to 1, and my justification would be v of t is less than 0. Part B, find all the times when the two particles are traveling in the same direction. So again, the key word is direction, and direction is described by your velocity. So I basically need to take two sign charts and compare their velocities. Now, luckily, we just tackled the velocity of particle P, and we made a sign chart for that in the previous question out. We had 0 to 1, and we had a negative and a positive. Okay, so now I need to get the sign chart for the velocity of Q. And I believe they gave us the velocity already. They had us at t squared minus 8t plus 15. So I just need to make a sign chart and set that equal to 0. So let's go 5 and 3. So I get t equals 5 and t equals 3. So I'm going to line that sign chart up right here. So let's see, 3 is over here and 5 is over here. Actually going to erase this little piece. That is awesome, Mackenzie. All right, and I'm going to test a 1. And again, I'm going to use this factored version. 1 minus 5 is negative, 1 minus 3 is negative, which makes a positive. I'm going to test a 4, and again into the factored. 4 minus 5 is negative, times a positive would be a negative. And let's see, if I plug in a 6, I get a positive. So now to answer the question, I have to see when they're traveling in the same direction, meaning their velocities, so here's Q of t, the velocities are the same. So I'm basically, when I say same, either both positive or both negative. So let's see, from 0 to 1 I'm negative, and from 0 to 1 here I'm positive, so that would be opposite. I'm positive from 1 on, so I would say from, let's see, 1 to 3, they're both positive, and 1 on, so then from 5 to, I believe it ends at 8. 8, they are both positive. So again, I'm saying when the v of t's of q and the v of t of p have the same signs. Part C, find the acceleration of q at time t equals 2. So let's just stop there. We need the acceleration of q. So I know the velocity of q, that was given. Okay, so the acceleration to take a few seconds. The acceleration of q, I'm just going to derive this, so I've got 2t minus 8 at time t equals 2. So now I'm going to plug in a 2. So that's going to be 4 minus 8 is negative 4. And they love this question. Is the speed of the particle increasing or decreasing at 2? And give a reason for your answer. So again, to justify whether speed is increasing or decreasing, I need to compare the v of 2 and a of 2. So we just discovered that a of 2 is negative. So a of 2 is less than 0. And v of 2, I just need to plug 2 in to my velocity. So that's this equation here. 2 squared is 4 minus 16 plus 15 is definitely positive. Therefore, I would say the speed is decreasing because a of 2 and v of 2 have different signs. Lastly, part D, they want us to find the position of q the first time it changes directions. So instead of them saying find the position at 5, find the position at 6, they're saying find the position the first time it changed direction. So let's figure that out. The first time it changed direction is when your velocity equaled 0 and it changed signs. So I think we have a sign chart for that. If you go find your velocity for function q, sign chart, look at your paper, you should have a velocity for function q sign chart. The first time it changed directions was at 3. So they're saying find the position when the time is 3. So pretty straightforward question. Find the position at 3. Always start with your initial condition, which they gave you. The position at 0 plus the integral. These are going to be the same, 0 to 3. If I want position, I'm integrating velocity. So now I'll just carefully plug everything in. The position at 0 was 5 plus the integral from 0 to 3 of the velocity, which was t squared minus 8t plus 15 dt. And just run through the order here. We get t cubed over 3 minus 8t squared over 2 would be 4t squared plus 15t from 0 to 3. So I have 5 plus that. If I plug in my 3, 3 cubed is 27 divided by 3, so that's 9. Minus 3 squared is 9 times 4 is 36. Plus 15 times 3 is 48. And I have 5 plus that amount from this 5 sitting here. So I think that gets me, is that 18? So I have 5 plus 18 for a total of 23. Okay. And there you have it. Again, if any of that was challenging, please redo it. Grab scrap paper and redo it for yourself. Lots of talking out loud. And I've heard that in a lot of videos from you guys. The more you talk out loud, the easier these are becoming.